Here in this video, we are solving a NEET 2025 question from a chapter Electromagnetism. The question is like this. A 2 ampere current is flowing through two different small circular copper coils having different ratios. The ratio of their respective magnetic field is how much, right? Let us try to understand what is given in the problem is. It's given that there is a circular coil who is carrying some current. Whenever there is a current passing around that electric field, perpendicular to that, a magnetic field is developed, right? Once if the magnetic field is developed, it is having poles, pole strength. So it must be having some pole strength. When compared with a standard bar magnet, it will also have a certain length. So it will have a magnetic moment as small m into 2l. It can be derived. Now I am not deriving, which is already done. You can just look into the playlist of this chapter. That magnetic moment of a circular current carrying conductor is NIA. N is the number of turns, I is the current passing, A is the area of cross section. Here in this problem, it was not mentioned that it is having different number of turns. So we shall assume that here the number of the turns are same. It is also given that the same current is passing through both of them, I1 equal to I2. So the magnetic moment is only directly proportional to area of cross section. Being a circular coil, it was given like circular, area is pi r square. Pi is also constant. So magnetic moment is directly proportional to r square. So m1 by m2 is r1 by r2 whole square. Their radii is in the ratio of 1:2. So 1 by 2 whole square. So the ratio of magnetic moments is 1:4. So it's a very simple question to solve. To solve this question, the only knowledge that you need is you need to know that magnetic moment is NIA. That's it. Thank you for watching.